Hi, everyone. Thanks for coming to the session today on sustainability in the brewing operation. Appreciate it. I'm here with good friends and colleagues, Sara Martin, who's principal and owner of Critical Path Engineering Solutions. She's going to talk today about some of the wastewater challenges and better wastewater management, as well as Tony Cordova, who is the lead brewer at Prison City Brewery. He's got a lot of really good best practices to share and things to look at when you're looking at data and things just to improve your sustainability. So from an agenda standpoint, we're going to kind of do a high-level overview. We're going to kind of talk about the importance of data and tracking, source reduction and reuse, as well as overview on wastewater treatment operations. It's really going to kind of touch on a lot of things that Ben had talked about earlier on his keynote discussion this morning. So from a high level overview on sustainability, our focus in our discussion today is to really try to help improve environmental footprint with breweries across the state, focusing on water use, wastewater management, energy use, chemical use, waste management in general. We want to try to really increase adoption rates on these best management practices across the state. We did back in 2019, we did a EPA grant focused on this, and we want to kind of walk you through some of the key findings from that. Things that was very well achieved by breweries across the state, but also some opportunities that we had identified. We want to share some of those knowledge and tools across what we learned, and some of the case studies and key resources have been identified on our site that you can kind of refer to as well. So for some of the overview focus areas, you can see on the left here, those are some of the areas that we're going to talk about with water use and monitor and pre-treating wastewater, using less chemicals, cutting down on waste, and just becoming more energy efficient. With source reduction type activities, we want to really focus on this upside down pyramid. We want to really focus on source reduction and reuse. We also want to work on focus on diversion. We really would like to focus on that initially. That's the prioritization. Once you get to the landfill, the opportunity is not as great. It's better to work in the source reduction and reuse if possible. We can touch on some of those as we go through the talk. With that, I'll let Tony take over. He's going to talk a little about the importance of data and tracking and some of the lessons learned that he's taken over his time.
Thanks, Ken.
Yep.
Hey, everybody. I just wanted to talk mostly about data collection, because you can't make an informed decision about where you're falling short with your sustainable or inefficient practices without that data. It's very important to collect this data so that you can make that decision and have a quick ROI. Most of the stuff that I'm going to be talking about is free. This costs you nothing. When the keynote speaker this morning said that a lot of the complaints from business owners is that it costs too much to be sustainable, I think that is just bullshit. You can do it. All the stuff is free. Just get the data, and the way you operate can create a sustainable and more efficient process. So the first thing I like to say is just start one at a time. One of the best things to start with is water. How much water is coming in? How much beer are you making? How much waste is going out? Most of these things are already tracked, so you can compare these numbers and make sure they make sense. According to industry standards, you should be between about 4.9 and 12.6 gallons of water for every gallon of beer you produce. That is the industry standard. It's a broad standard. It's obviously very large, but obviously you want to be on the low end. It's not that hard to collect this data. Talk to your local municipality. You're probably paying for water. You're probably paying for waste. So all that data is already there. Put it in a spreadsheet and figure it out. How are you being charged for waste? Put that in a spreadsheet. It's not that hard. All those things, do these numbers make sense? If they seem out of line, if you see 13, 14 gallons of water per gallon of beer produced, you can further analyze where that water is going and how it's being wasted. This is a good map of the waste centers. Sara put this together. This is just a general map. This doesn't apply to every brewery, obviously, but you can put this together and find out exactly where your waste is, and you can apply a number to that. You can apply a cost to that, or you can apply a gallon number or a kilowatt hour or anything to these waste centers, and you can see where you're out of line, or if they make sense or not. This is actually a really, really good way to analyze this information. And it's actually very, very simple too. And you can lump this into certain things. It's all going to be depending on how your brewery is set up. And then this is a good example. This is a spreadsheet that I put together for when we were brewing. We're calculating the water in and wort out. So as you can see, it's the date, and then the batch number, and then the amount of water that went into the beer. So that was all metered. We had a flow meter on our brew house. Flow meters are not that expensive, so I would highly recommend getting flow meters. And then our wort out was also measured. That percentage of water loss, does that make sense? Are we, if you're making a new beer and you write the recipe and you put it into the spreadsheet and you say, oh wow, I got 30% water loss, but I'm used to 25% water loss. You can adjust your recipe based on that, and you can use less water. And then furthermore, just kind of the post-boil, I would measure the amount of wort in the kettle with a dipstick. Not that scientific, but we had a meter on the way out, so I could tell that I had true loss, and that true loss, does that make sense? Do I need to, if I'm doing an especially hoppy beer, is the amount of trub that's in that I'm losing, or the amount of beer that I'm losing due to trub, is that a problem? Do I need to move to cryo hops? Do I need to move to hop sauce or incognito or something like that to hopefully fall more in line with what is expected here? And that predictability helps you make more informed decisions when you are writing a new recipe, when you're trying to maximize the potential of your brew house, and become more efficient. That makes sense? Yeah?
Yeah.
Very, very, very easy thing to do. Literally, I already had the data at my fingertips. All I did was put it in a spreadsheet, and all of a sudden I was able to make informed decisions about it. Let's see. And then next, so this is something that I was reading about recently that I found to be it stuck with me because time is obviously a very valuable resource. Payroll is a very valuable resource. Having a rhythm with the way that you operate your brewery is a great way to create predictability, and a great way to understanding how much time and what and how you can efficiently move through the day and through your processes. So in this example, this is a general example. Obviously, everybody's going to be different. But if I know, I mash in at 9 a.m., I know that at 1:45 or 1:35, I should be done brewing. 4 hours and 35 minutes. Hey, now I know, because I have the data, that I can brew a beer in 10 hours, no problem. Obviously, there's going to be variable as far as louder time, could be a little bit longer, etc. Those variables are always going to be inevitable when you're operating a brewery, as we all know. But this kind of predictability makes you go, okay, now I know I can brew 2 beers in a day. I don't have to stretch it out to 2 days. Maybe that means I don't need to buy a certain piece of equipment to supposedly make my life easier. When you already have the data, you can make that decision and you know what you're capable of. 4 hours and 35 minutes is definitely possible. I've done it. It's great. Actually, fastest brew ever, 3 hours and 30 minutes. Great. It was a fun challenge. Anyway, so we're gonna go through some other stuff that we're gonna talk about a little bit later too. A lot of the stuff you already know, but I'm just kind of trying to help you figure out to collect that data and how to maximize your efficiency. Consolidate the supply chain. We talked about it this morning a little bit. Talk to your local suppliers. Talk to your local brokers. The Hop Guild is right here in New York, and for some of us, it's right around the corner. Your local malt suppliers, all that stuff. Those people are going to be the people that you create relationships with, and when you create a relationship with them, now you are you're your friend. They're your friend, and when you need something, hey, they're right down the road. They're going to help you out. Lots of times, they want to sell it to you. They want their product out there. They will help you out in certain ways. All those things are great. You know who's not probably going to do that? Country Malt, BSG. You're just a number in their spreadsheet. Creating those relationships helps with the efficiency and usually helps with shipping too. They're shipping from Germany or they're shipping from wherever. Shipping is incredibly inefficient and unsustainable. So shortening that supply chain is very, very valuable. And then, getting the best utilization out of your malt and hops. That's going to be for you to decide. When does it make sense to get super sacks? Does it get a silo? All that information is out there and available. Ask your malt supplier. They will help you help you make those informed decisions, and based on how much beer you're producing, cryo hops, etc. Growing your yeast. I'm also talking tomorrow at the yeast handling presentation. It's so you get so much more higher profit margin if you are reusing your yeast. It's very, very important. It's very easy, but I won't dwell on that. If you want to see it, go to a yeast seminar. They're very good. And then gas and electric. This is going to be a little bit more complicated. Obviously, you need to collect bills. NICEAG. I don't know how many of us are on NICEAG, but they make it incredibly difficult to extrapolate that data. I think they do it on purpose. Sometimes that electric usage is variable, and it also varies on seasonality. But if you collect a year's worth of data, you can kind of see the trends and see if those things make sense. Again, we're collecting data to see if they make sense based on the way you're operating. If you see spikes, you can go, okay, is there an issue? Maybe I can meter a specific piece of equipment to see if there are issues there and hopefully get ahead of it before it becomes a bigger issue. Also keep in mind fossil fuels are a finite resource and it's something that we need to be thinking about, and unfortunately with the craft beer industry it's very difficult to kind of push that because we're all just trying to get by, but keep that in mind and try to keep all those supply chains and everything short. You know, we're all using gas. It's not very good for the environment. I think we all know that. And then CO2. Here's another good example of industry standard. About 1.8 to 2 kilograms of CO2 per 1 hectoliter of beer. And if you collect your CO2 bills monthly, bi-weekly, whatever it is, you can track that data and see if you fall within those industry standards. Industry standards are out there. You can go to the BA. They're in books. They're everywhere. See if what you're doing is actually falling within the industry standards and hopefully on the lower end. If you're below it, great, don't worry about it, and just move on to the next thing. All right, and then chemical use. These are all things that you guys probably already know. I'm just more talking about like how to calculate it. Get testing strips, get titration kits, meter the water, your rinse water. You know, say it takes me 40 gallons to rinse a tank. If you're not metering it, you're just going open, close, open, close. All of a sudden you've done 100 gallons. That's just wasted water that you're actually paying for. So just keep those things in mind. Consider a CIP card. I'm not really convinced that the ROI on CIP card is like there, but it is a good way to reuse chemicals. A simple caustic brink, very, very effective at reusing chemicals and very, very cheap. And then you can also reuse rinse water. It's very complicated, but it is possible. Wash down floors, rinse tanks, that kind of thing, but you usually have to have a separate brink, separate pump, that kind of thing. If you can, sure, but that's a good way to do some reuse. And then, where does your product go? How's it get there? Is it going to be on a truck using gasoline? Probably. Where is your tap room? Is it right across the wall, or is it 15 miles away or 20 miles away? All those things are things to consider because we're talking about sustainability. So, does it make sense to even drive your product up to the tap room or get a distributor that kind of thing. Most of the time, if you have all these numbers, you can make that informed decision and hopefully not waste money just trying to get your product out there. I get that the product has to go somewhere, but very important to think about that. Focus on the high cost centers first. If you know that you're spending way too much on electric, start with electric. Once you win that, if you figure that out, all of a sudden everything will be much easier. Just try to identify what is the most expensive. Is shipping your product the most expensive? Focus on that first. Figure out how to reduce that cost and make it more sustainable. Recycling is so easy, and a lot of people are just not doing it. They see the recycling bin full, they throw the can in the trash. Just try to keep that in mind. And then the most important thing is personal motivation. Stay motivated, stay sustainably minded. Honestly, like if you do that, it's like safety. If you stay safety minded, you're gonna be safe. If you stay sustainably minded, you're going to keep those things in mind. It's all about attitude. And then some other like little things. Buying new versus used. Obviously, a new piece of equipment is not made yet, so you are creating waste by creating a new piece of equipment. Used, it's already there, so you're not creating that waste. You're actually reusing that equipment. Careful planning, plan. If you plan correctly, you may not even have to buy that equipment because you've already created a system that works. Maybe it's also reducing the amount of time of beers in a tank. If you reduce beer from 21 days to say 18 days in a year, that could be the cost of a tank, and then you don't have to put that there. Valuable real estate in your brewery that you don't want to clutter up with equipment that just because you're operating inefficiently. And then again, mindset. It's so important, and it's a great way to move forward. And all that stuff is free. Cool, thanks.
A lot of great stuff for sure. That's awesome. I work at RIT, and I help really reduce environmental footprint for different companies, including breweries and wineries across the state. And probably about 3 years ago, we started an EPA grant focused on trying to help source reduction initiatives across the state. And so we did probably about 11 assessments with the different breweries that are identified here. Kind of high-level assessments, kind of general assessments, kind of walking through the process, identifying where there's great opportunities and things that they were already doing really well on, achieving a lot of really good success with sustainability in mind. So listed here are all those breweries that we work with. So you can see Lucky here, Paradox, I know Paul's in the back, and Devin, and so you can see some of the other ones, and a lot of really good stuff already being happening across this group of breweries and across a lot of the other ones as well. I think Tony's right. I mean, you got to just start somewhere. Go for those high cost centers. Usually monitoring and tracking is a way to start, kind of to identify where there's opportunities. But you don't have to tackle it all at the same time, or you're going to go broke. And I'll make sure I send these slides to whoever wants them. But we've identified and collected a lot of really good resources for brewing and just source reduction and best practices. So if any of you guys want that, let me know. A lot of focus on sustainable supply chain stuff and just sustainability within the brewery operations, case studies from previous assessments that we've done, past webinars and trainings as well. So there's a lot of really good resources that we have. I've had some discussions with Paul Leone to put that on the New York State Brewers Association site as well, so it's going to have a good linkage there. But if you want it quicker, just stop by afterwards and I can give you that stuff. So one of the things I know Ben had talked about up front this morning was on the impacts, sustainability impacts. Our discussion today is on the brewery operation, but you got to remember 20% of the industry's impact is outside the walls of a brewery. You know, it's a lot of the supply chain stuff. So you have to think of that. You know, some of the upstream activities is the processors and manufacturers and the logistics. So the farms, so that's a lot of the upstream. A lot of the downstream is the distribution and the warehousing and the shipping and the consumers. So those things you have to focus on, even though our discussion today is on just the brewery operation itself. And I kind of copied and pasted this from what Tony said, but you really have to focus on consolidating your supply chain, looking at your raw materials, and then trying to maximize your efficiency. I think I wanted to kind of echo that just because it resonates, and that's an area that you should look at because it could be a high cost item for sure. And then just to kind of build on that, you know, look at all of the waste generation areas within the breweries. And you look at the brewing process and the packaging and the food service. So look at all of the outputs and then specifically identify what you can do with those things, which I think is really key. Another thing that Ben had talked about this morning was the energy maps, the EPA energy maps that are identified. There's a lot of really good resources on that Energy Smart website. A lot of information on just becoming more energy efficient and kind of walking through that whole treasure map. And you can do it collectively as a team. If you give me a call, I can even give you some information on the details and the documentation. You don't have to do all of it, but you can at least take pieces of it and kind of walk through. But there's a lot of really good stuff. Things like implementing heat exchangers and scheduling the production schedules based off what Tony had mentioned, insulating your pipes and installing LEDs, encouraging just energy smart habits, which is really cultural type changes across your brewery. Another area is on water use. Reducing water use isn't just on saving natural resources, which is the most critical, but it's also reducing the load off your wastewater treatment. So it's a twofold benefit, really. We do a lot of work with reusing water within RIT and P2I, and that's an area that we're always focused on. But installing water meters is a quick one to go after. Reusing water where possible, such as rinses and cleaning cycles. Using CIPs is a great way to do that. Considering low flow nozzles and fixtures, and then implementing like sensors and precision control methods, I think is always key. You know, and I know Tony already kind of walked you through the makeup of the beer to water ratio, but it's important to remember that, because if you're well above that, you really should start to kind of hone in and try to figure out what's really impacting your water to beer ratio within your operations. Some of this is a repeat of what Tony talked about, but CIP will help with chemical use. It standardizes chemical use, but it also it helps with your water use as well. There's another thing to remember is rotating cleaning chemistries could be helpful, because it's really going to decrease the chance of resistant bacteria growth. So if you're looking at different types of cleaning chemicals, you may want to at least investigate that as well. That's a really important one. And then trying not to overuse chemicals, using test strips and titration kits, I think is really helpful. So another one, I think this is really key, especially as any kind of surcharges are being applied to your brewery. You want to keep the organics out of your water if possible, depending on the size of your brewery. But you really have to kind of side stream waste as it makes sense to try to get those organics out. And it really changes. You can see there's spent grain and sweet water and spent hops. a lot of this information I collected from the Brewers Association, but really, you should at least identify high BOD areas, try to reduce that as best as possible. Finding a possible use for those byproducts, I think, is going to be really key. It's not going to happen all at once. It's a journey. You'll have to take a little at a time. But I think it's important to really look at side streaming and collection, because you want to try to reduce your loads before you have to treat it, for sure. It's going to save you a lot of money in aggravation in the long run.
I'm a little late to the conversation, but is there any benefit to kind of the biomatter of brewery waste for the energy of the wastewater treatment system?
Yeah, I think that's probably an area that you talked about, right? Yeah. So it's good. It's a good lead-in, actually.
Oh, great.
So Sarah was going to talk about that next, I think. So that's it. That was a good segue. Thank you. Yeah. Great.
All right, thanks, Ken.
Yeah.
So, you've done everything you can in your brewery to reduce the amount of waste going out the door. But at the end of the day, you're still left with volume of water, and the amount of soluble pollutants are typically something you just can't get out. There's only certain things that you can do with that. But wastewater treatment is most likely, especially if you're growing and expanding, it's going to be a necessary evil that you have to face at some point as you grow your breweries. So when you're left with wastewater, the first step is, okay, I have this now. Unless you're going to evaporate it, which is very cost prohibitive, you have to find somewhere an outlet to discharge it to. So the first thing, you can't design a wastewater treatment plant without knowing where you're going, because each place that you're going to go with it has a different standard for the level of treatment that you need. So whether you're in the middle of a city, or if you're out in the middle of the Finger Lakes, or these all become important things to understand where you can actually discharge your water that will affect how you can treat it. So the available options, outside of evaporation, which not many people do, you can discharge to subsurface. There's intermittent stream, so that would be if you're located on like a small body of water, typically like a river or a small stream. There's also small bodies of water, that would be a small lake or whatever. Sewer with pretreatment, and then a sewer without pretreatment, which is, somebody asked me when I here today, they're like, we're growing, what should we do with our wastewater? And I'm like, find a sewer. That is the easiest, and we'll go through that in a second. Obviously, if you're very small, just haul it away to a larger place that can handle it. Land application is another option, using it on crops. But this comes with its own rules. You cannot have any human waste or chemicals in the wastewater. So that can only be organic water that resultant from the brewing process that has no CIP in it. And obviously sanitary wastewater cannot be in that. And then reuse or irrigation these are pretty much the major buckets of where your water can go. And I'll kind of go through each of those, but being an engineer, I speak process flow diagrams. So this is a little process flow diagram that I put together for working with RIT just to help guide people. And basically, the first thing you got to think, and I always say this, is, first level is there a sewer available? That is the first thing I ask everybody, because at the end of the day, while I love building in new treatment plants, it's fun, there's really not a very good answer out there for you guys yet, as far as, I say yet, because we want to work on it, but as far as a economy to scale with wastewater treatment for smaller craft-sized breweries, there's just no slam dunk answer out there right now. So if you're near a sewer, that is always going to be your best way, and to get as many pollutants as you can out of it, to reduce surcharges, that's a cost as well. But typically what you're going to find is your wastewater, without good capture and side streaming, is going to be anywhere from 10 to 20 times stronger than human waste. So a sewer is not going to just say, yeah, put that down there. So typically they're going to want some level of cleanup before they do that, especially if you're on, one thing I'll caution you on when I say find a sewer. If you're on a sewer for a 1 MGD plant in a town of 3,000 people versus a 100 MGD plant that's servicing 300,000 people, most likely that larger plant is going to be a lot more lenient to what you put down the sewer than a 1 MGD plant. In fact, there's been case studies where, a vat of beer unfortunately got discharged down a sewer and has wiped out the treatment plant downstream. So sewer isn't always the easy answer either. You still have to make sure that you're not putting your raw product, high organic waste accidentally down the sewer. You're going to have people knocking on your door. So I'm going to say sewer is a good answer. Pre-treatment, ideally segregation. But if you do not have a sewer, what I'm finding in New York State is the next kind of answer that people are going for is subsurface. And then really what it comes down to is, for what Tony said, you got to look at your costs and your volume. So what I'll tell you is that if you have anywhere from 1,000 to 5, or if you have anywhere less than 1,000 gallons a day, I typically tell people to look for outlets for your wastewater and don't build a treatment plant, because it's just going to be typically more cost effective to haul that somewhere where they can find a better way to treat it. But you'll have to do your economics. If somebody's going to charge you 50 cents a gallon, well, then that's not going to work. But what I typically see is 10 cents a gallon, and you can kind of do the math. But we'll kind of go in the economics of treating on site, and you'll see why I say that that's not so bad. The other thing to look at is seasonality. One thing we found, I was working at this one brewery, and they had a lot of summer events and concerts and stuff. And to build them a wastewater treatment plant for the 3 months a year that they have some excess flows, is kind of crazy when you look at the economics. So what we decided there is we built a smaller one, and then any excess, we had a diversion tank, and they would haul during summer events. So if you gotta kind of look at your brewery is if you have a destination brewery where there's people, does it make sense to build something for the small time that you're gonna have peak flows, or just for the lower time and then shave off the peak flows by hauling? Again, economics will kind of dictate all of this. So can you get, I guess the next decision point, and this all goes through that process flow diagram, is can you get beer production wastewater free of sanitary wastewater and chemical, and do you have land near you that you can grow crop with, or during the winter store it and then apply it to the crop in the summer? These obviously are more for breweries that are out where there's a lot of land available and or potential land disposal methods. But as long as you keep the sanitary wastewater out, you have more options, let's just say. And then I will say this, if you're building a brewery, one thing I always say, if you're in the middle of nowhere and you're building a brewery, you may want to consider separating your human stuff from your beer stuff, because they do have different outlets. So if you're building one, I always advise, you can always mix them later, but you'll never be able to do that plumbing again. So try to separate them so that you have options for waste disposal. Because once you start mixing the sanitary stuff, the human stuff, it gets a lot more complicated. The next decision point, I talked to you about the cost of hauling, and does it justify? So this is where typically I'll get involved, and somebody will come to me and say, hey, I want to double my production. What does a new treatment plant cost? And the reality of it is, by the time you do all of the equipment and site development and, finding an outlet for it. If you're going in the ground, you have to do a ground dispersion system. You have to kind of dissipate, just like a septic system. You have to dissipate that water into the subsurface. So it's not just inject it in the ground. It's got to kind of trickle in the ground. But by the time you get done with all of these, you could be anywhere from 50,000 to 500,000. And like I said, I wish I had a better answer for that, but that's just the reality. And then it's not done there. So the other thing you have to do is pay for operations, chemicals, labor, and I'll tell you, running the organics, the soluble organics in there typically justify a biological system. And you guys have enough headaches chasing the biology to make beer. Now you have to chase the biology to chew up the organics, and they're different biology, and sometimes they're really finicky. So what I'll tell you is wastewater treatment not only comes with a higher capital cost, it's very tough for small breweries, but it also comes with an ongoing cost to maintain, operate that system. And anybody in this room who operates one could probably, there you go, Paul, could tell us it's not easy and it's not cheap.
No, we spent about 600,000.
There
So
you go.
when we were building the new brewery, we had 3 10,000-gallon tanks under the slab. Since then, we have a MBR system in there, but we've modified it over the years to get it working. And we sent somebody to school, college courses, to get trained in it as well. A lot of chemicals, but we also just recently added a screw press to press out the waste stuff, so we can move that for composting now. So we're actually losing water and putting it back in and processing it again.
So
It was a learned lesson. Thank God it was during COVID. So
No, and that's a good point too. With biological systems, you're growing microorganisms you're basically growing a microorganism to chew up the organics for you and treat the water through that process. Those bugs keep reproducing and making more bugs. So now you are, to Paul's point, they put in a dewatering system because he was probably your hauling costs were probably through the roof, right?
around 2,200 a month.
Yeah.
But that was also called for our side stream tanks. We have 2 3,000-gallon side stream.
Okay, so that wasn't just the biological
No,
science.
no,
Yeah.
no. But with the screw press now, we're able to combine the bio with this, and then it coagulate enough so that we can process that now. So now we're not sending anything to the septic company.
So I'm not discouraging you from wastewater treatment. Trust me, I've been doing it my whole life. I'm just saying it's not easy, and it's something that has to be well thought through. And that segue for the next one. So, when I first got into wastewater treatment, I did human stuff, and that was pretty easy, and it was kind of like, okay. So why I kind of gravitated to industrial wastewater and breweries is it's difficult. It's challenging, and so what we're getting hit with is different pHs, different temperatures, all of which, as you guys know, because you use microorganisms, they don't like highly variable pH. They don't like high temperature. I mean, that's what you use to kill them, right? So we have all of this coming down the pipe at our bugs too. So pH and temperature, they have to be thought through, or all the investment you make, you're just gonna wipe them out. Organics, one thing I've seen is people not, what you'll see is some people come in and sell you a wastewater treatment plant without doing the proper science behind it. And what I'll tell you is this ends up in a ridiculously oversized plant that you spent way too much money on, or a ridiculously undersized plant that you wish you had spent more money on. So this sampling is super critical, and understanding the variable is super critical to getting you the plant that is right size for you and to maximize the money. If you have to make the investment, make it the right way, right? We're talking maybe $5,000 worth of sampling here that could save you hundreds of thousands later on. So we talked about seasonality, understanding your seasonality. Do you brew more at a certain season, summer maybe? Do you have concerts? Do you have influx of a lot of people at certain times? You got to think through all of this and then make sure that whoever's designing your treatment plant understands that so that they can factor that in. quantity, variability, strength, you guys are a batch process, so make sure that somebody designing for you understands that and understands that sometimes I'm doing this and sometimes I'm doing this. And when I'm doing this, this could be like a pH of 2 or 3. And when I'm doing this, I'm gonna have a pH of 11. Make sure that your designer fully understands what's coming at them. As much as we want to divert and keep things out, we all know that spills happen. We all know that somebody hits the wrong valve or somebody puts the wrong hose here or something like that. So put that contingency in your plan because things are going to happen. Make sure you have a system that can react and people can handle it, basically. Understand what chemicals you're using. There's chemicals that just wipe, just like you're using them to wipe out bacteria in your tanks. They also wipe out bacteria downstream. So understand that there's certain chemicals. There's ones the bugs can handle, and there's ones that are just like quaternary ammonium compounds that are just not forgiving at all. So understand if you're using quats, try not to put them in a biological system downstream. Understand your expansion. Like if you're going to put this infrastructure in, you really need to do master planning and understand what you're going to do in 5 years. Because why? Or make it modular, right? So that if and when you expand, it's an easy add-on to the system. Or if you're going to expand in the next 2 years, invest the capital now instead of later. So understand where you're going to when you design a system. And then, like I said, the easiest way in wastewater treatment is to get as much solids as you can out. So, for instance, we did an anaerobic system at Brewing, and they put a fine screen upstream and then some settling. And just by doing that, they were able to remove a lot of their particulate matter that was causing difficulties downstream. So look at your wastewater and, make sure you can get as much of the solids out because that's kind of like the easiest thing you can do. It doesn't require bugs, doesn't require anything else. It's just physical science of separation. So if you have to go and invest in the necessary evil, my suggestion is to work with DEC upfront and identify what they will allow you to do rather than get too far down the road and realize what you can't do and you've already invested money in. So DEC, I believe, has talked about a guidance for breweries that I don't know where that stands, but there may be in a couple years as breweries grow in New York State a guidance out there from the DEC for you guys. But in the meantime, the best thing you can do if you don't have a sewer is contact them and find out what your options are, where you are. If you have a sewer, you're not contacting DEC, you're contacting the sewer authority that you live. And then if you're doing that, understand what discharge limits you're gonna be subject to because that's really gonna dictate what treatment you need. Engage, I don't mean to tout engineering, but we are also the necessary evil. Sometimes it just helps to have somebody guide you through this process. I do suggest, I know engineers are expensive, but I do suggest even a consultant to guide you through the process. It may just save you money later on. And sampling, I talked about sampling. Make sure you do your sampling and really understand what you're designing for. So this goes to that question you said of, I believe you were talking about producing biogas from the waste.
No, just in general, on the sewer system, if the biomatter from beer, the true, the hops, whatever going in there has any benefit to the microbial activity, I guess, of the wastewater treatment plant?
No. The answer is no. So what that does, so anything you put down a sewer that's higher strength material, typically will, when it goes to the municipality, the first thing they do is degrit and settle out and screen stuff out. So your tube is going to most likely settle out. Anything that we filter is going to be, or screen, is going to be screened out. And then all the soluble matter that goes on further from there is just going to take up more energy for the aeration, the blowers and the bugs to treat. So if you want sustainability, get that stuff out up front at your plant and go find a digester to put it into, or a compost, or some other. So municipalities typically have digesters. You could contact them and see if they'll take your waste. There's plenty of agribusinesses that'll come get it and they'll find digesters for you. Depending on where you are, I could give you suggestions. There's plenty of people now that are kind of in this waste area, trying to get organics out of landfills and into beneficial reuse. So if you have questions, let me know. But what I would say typically is, and this is where this chart comes in, everybody asks me, should I build a digester? And this chart kind of goes through, the answer is typically, unless you're really big, no. So, kind of, again, another process flow diagram, because I'm an engineer, but typically, this kind of walks you through, but the reality is this: 10,000 pounds of COD a day, which is a lot. That's a big brewery to produce that much, is 50 CFM of biogas. And that can barely power a boiler. So that's kind of what, it'd be great if we could all do anaerobic digesters because they create gas but the reality is the economics don't work for small breweries very well. So, and this is kind of a decision chart that helps you walk through the process of what type of waste you have and where you want to go with it. But the major process is anaerobic versus aerobic. Anaerobic is the microbes that don't use air and create gas. Aerobic is the bugs who use air to break down solids. That's what Paul has, is aerobic treatment. And for smaller breweries, aerobic's gonna win out over anaerobic any day. The big guys, Miller Coors, Budweiser, they all have anaerobic digesters, but they also have a ton of waste, and they make more like 300 to 500 CFM of biogas. So enough to power a full boiler and then sometimes engines. So if you're gonna go, you're gonna be approached a lot by vendors for vendor package solutions. Couple of things here. Watch for controls. Make sure you understand your daily operations that you're gonna be in charge of when they leave. What's the aesthetics? How do you operate? Are you getting quality equipment and instrumentation? Or are you getting stuff that's going to break down in a year? So make sure that when somebody sells you a package that you know what is in that package, because that is typically much more affordable than going through an engineer. I'm just going to tell you that. But with that, you just got to make sure, look under the hood at what you're getting and demand what you want. And that's it. Thank you. Anybody have any questions?
Any questions? But that shows that last thing for biogas, there's like budding ports then used to boil their steam.
I'm sorry, what?
There's like budding ports take that biogas and go through the boiler and use it like burger the boiler.
Yeah.
So they're actually doing that, or is that just like something they did?
No, people use it in boilers all the time.
Okay.
Yeah.
So the breweries are implementing that?
Yeah.
That's awesome.
Yeah. I mean,
Yeah.
so like Matt Brewing in Utica, they have an engine. They're not using a boiler. They have an engine. So they're actually using their gas to create electricity there. And they are more in that 10,000 pounds a day COD range. Because, I mean, they're a medium-sized brewery, and they produce some decent, enough waste to justify a digester, right? The bigger guys, typically, as you know, heating demands are huge at some of these larger breweries. So, and you get pretty much with a boiler, you get like 80% efficiency versus an engine. You get a little less efficiency and more maintenance. So if you can throw it in a boiler, I'd say it's the easiest way to go. But you got to have enough waste to kind of justify it.
Any other questions? Thank you.
Thank you,
all.
guys.
I appreciate it.